Muted.
I got that thing muted. My
I
bad.
don't think you're sharing either.
You know what it is? It's a rainy day and I don't feel like sharing.
I know. You want to clam up and go inside your cave.
I do. I wanna just sit at home and watch movies on TV.
Yeah.
Watch some Lost in Space.
Lost in Space. Actually, that's a very good series. I was surprised. The Netflix one you talked about. Right?
Yeah.
That's actually good. I was thinking that would not be so hot, but it did a good job. Good writing, strong characters that make you watch from episode to episode is kind of what you're looking for. My only disappointment was I felt that the alien world they went to was too much like Earth.
Yeah.
They didn't have the budget, I guess, to make it too alien.
I mean, they used all their budget on the robot.
They used all the budget on the robot, the spaceships, obviously the effects, and whoever does scar application, because everybody's got their faces cut like every other scene they get hit by something else. But it's good. I liked it. If you have a chance to check it out, Lost in Space, the reboot by Netflix is actually pretty cool. Good characters. I really enjoyed that. But back onto what we're talking about, UVs. As I was saying before, you're really going to have to dial in for today's lecture. You're going to be taking notes. If you've never written anything down in your life, you're going to have to write stuff down for this lecture. I explain it very straightforward, and again, the broad strokes of UV mapping make perfect sense. They don't seem complicated at all. But what happens is periodically I'm going to say, and these are the steps for whatever, and then you have got to have those written down. Because if you are missing even one little piece of the information, you're done. You're just spinning your wheels. You can't go anywhere. So you really, this is the day to not miss it. And if you're watching this digitally and rewinding and playing, really your better bet is to write this stuff down. Take notes along with the video. Because like I said, if you've got one setting wrong or one step out of place, this process doesn't work. And it's just dead in the water. And I gotta be honest with you, I have books for other people to teach UV mapping. There's really not a lot of it out there. I don't know why, but there's not. So really, this is where you're gonna get it. You're not gonna be able to Google this later or something. Again, dial in, make sure you're focused, asking a lot of questions, make sure you're doing the activity with us because this is your first chance to try to get this straightened out. I know sometimes I see you guys working on some of your assignments when we're doing activities and stuff, which is ill-advised to begin with. About 2 hours you're netting is really not that beneficial compared to the information you're missing. But today, worst choice you could possibly make to not be totally on board with what we're doing today. Does that make sense? And again, I just put that out there because I don't want you to make that call and then realize you made the wrong one. So make sure you dial in today, you're going to need it. Because your week 4 assignment, which is worth a tremendous amount of points, is all UV mapping, all of it. So you've got to know how to do this or it will punish you mercilessly. Does that make sense? Okay, hell yeah? Hell yeah. So just trying to keep you prepared. Again, I'm not trying to scare you, prepping you so that you can make a better decision, because that's my goal. Informed people make better decisions. So what we're gonna do is it going? Is it working?
Yeah, but it was using your laptop microphone.
Oh, really?
This one.
Oh, yeah, my laptop
on, right?
microphone stinks. This is,
Yeah, it's on.
yeah, it looks like it's on. Am I jumping the needle?
Right off the record.
That's what I'm talking about. Pump up the jam. There we go.
Yeah, you fit now. All squared away.
Yeah, there we go. Now we're laying it down.
LP.
And other cool music recording type terms. All right. Sweet. Let's do this. Let's talk about UV mapping. All right. So first things first, let's talk about UV mapping. Why do we even do it if it's so scary? UV mapping is the process of taking a complex, curved 3D surface and trying to lay it out flat. The premise is we want to create textures. We want to be able to paint on our models because they look so much better when you apply a texture to them, night and day. And for me, I really enjoy the texturing process because that's taking our objects one step closer to looking real, whatever they're supposed to look like. And for those of you, any of you guys paint? Any painters out there? Watercolors, acrylic, oils, anything like that? If you love painting, you're gonna love texture mapping because textures and painting textures is just like
painting. It's the same idea. Highlights and shadows equal transitions in shape, and you basically paint your textures, whatever it is you want to make, if you're utilizing Photoshop. So this is a cool step towards getting us to where we can paint those textures, and that's why we create these, we go through this UV mapping process. Now, in terms of the UV mapping, just so you can kind of get a broad stroked idea of what it works like and how it affects you, we're going to use mapping from our world because it is kind of similar in a lot of ways. First things first, let's assume that I invite you all to come hang out with me and Brian at our summer getaway in Attu, Alaska. And you might say to yourself, hey, well, how do we find your totally awesome hangout pad when we get there? And I say, well, if you imagine the island looks like an elephant, you fly over his head to the first wrinkle in the back of his neck, and then that's where we are. We're in Earl Cove. Now, that might work for you depending on your perspective. Number one, you have to see an elephant when you look at that. Do you guys see the elephant? Do you guys see it? By show of hands, how many of you see the elephant? This is totally a Rorschach test. No? Okay, a couple of you see the elephant. So you guys are on the same page with me. So, elephant, first you have to agree that's an elephant. And second, you have to be able to fly high enough in the sky where you could determine that where the elephant is and then try to fly to the back of his neck. But if I create grid coordinates, if I organize it and make it digital, and I tell you C2 is where Earl Cove is, you can find that instantly. Does that make sense? I'm taking a broad-stroked analog concept, an ambiguous form, and I'm organizing it, I'm structuring it in such a way that it makes understanding between a wide variety of people, because if you know numbers and alphabet, you can find it. Does that make sense? Yeah. Get a hell yeah? Hell yeah. Okay, so mapping in the world, mutual understanding. UV mapping of geometry, mutual understanding. The difference is, when we're mapping the world, it's mutual understanding between you and me. When we're mapping UV geometry, it's a mutual understanding between you and Maya, because you both have to understand where you are on any given point. Does that make sense? Okay, because that's texture placement. All right, now, so how do we do something that's complex and curved? Because Attu, Alaska is relatively flat, despite Christopher Columbus, relative to the Earth. Well, we can map curved surfaces as well. We can use longitude and latitude as lines to create a grid coordinate system where if we know the exact coordinates of longitude and latitude, we can find any point on the surface of the Earth. So if there's a complex curved surface, and we can organize that as well, even though it's not flat. Now the complication is, number one, if your map is a globe, you can't really put it in your pocket, right? That's not very easy to travel around with, and you can only see whichever side is facing you. So if you're trying to see the whole surface of the Earth, all of it, you know, because you're going, you know, that far from point A to point B, you need a different kind of map. How do I lay that out flat? Maybe you've seen a map like this before. How many of you guys have seen a map like that before? Okay, quite a few of you, that's good. So again, the idea here is I can see the entire planet laid out flat. And if you look at it, you can imagine how it might fold back up and make a spherical object. Does that make sense? You can kind of see that. But in order to take something spherical and lay it out flat, you'll notice I had to put some strategic little cuts in there to allow it to lay out flat. Much like if you peeled an orange, there'd have to be some breaks here and there. We call those seams. Make sense? Like the seam in your shirt, the seam along the leg of your pants. Except when we're talking about UV mapping, they're called texture seams. Does that make sense? Texture seams, where there's a split in the flat representation of the 3D object. Now, here's a question for you. Where did they place the splits on this map? Where did they create the little slices? Over the ocean, right? Do you think that's by coincidence that that's where they decided to split it? No, not at all. Because when we're creating a map, just like when we're UV mapping, there are more ideal places to have a seam and less ideal places to have a seam. Does that make sense? Now, since this is complex geography, and this map is really concentrating on the idea of the world's land masses, the water's just blue. So blue, a big broad scope of blue, that's an easy place to put a seam, right? They don't want to put a seam through a landmass because that might compromise the integrity of the map that we're creating. Does that make sense? That split will be awkward. Now, if we were doing a topological map of the bottom of the ocean, right, where the mountain ranges are and so forth, under the water, that's our primary concern. Oh, maybe we put the divisions through the land masses at that point because we're really more concerned with what's going on underwater. Does that make sense? What's important determines where we put seams. Does that make sense a little bit?
Yeah.
Okay, good. So again, we can create the Earth laid out flat like this, and that works pretty well. So when it comes to models, what we do is we take a complex 3D surface and we lay it out flat in a series of little maps. And they all fit inside of this area here, which is part of a window that I haven't shown you yet, but it's a window in Maya called the UV editor. The UV editor. And each of these is called a UV shell. And that UV shell is basically a very small map of the surface of a complex object, but laid out flat. Now you might be wondering, well, why do we lay it out all flat like this? Well, because we can take a picture of this space right here, and we can take that picture and bring it into another application like Photoshop, and we paint on it. And literally, wherever there's a shell, that's where we paint. It's like paint by numbers. So here's my character's head. There's his little face. So if I want his face to appear right there, I can paint right on this. Because we're used to painting on flat things, right? Like paper. It's hard to paint on something that's curved with any measure of accuracy. Does that make sense? We lay it out flat, super easy to draw and paint on. That's what we're trying to do. Take this, make it flat, because it's easier to paint on. And the grid coordinates of your UV shell correspond to specific grid coordinates on your models. Does that make sense? Mapping, but now objects rather than places. All right, now, again, inside the UV editor, which is a special window in Maya that just deals with UV shells, right? And you can see, I'm going to show you the window in a second. This is the UV layout for this object. And the way you see the UV layout for an object is you literally select the object in object mode, and then you can see its shell inside that window, the UV editor. Does that make sense? If nothing is selected, you don't see anything in here because UV shells are specific to the objects you're selecting. Does that make sense? Okay. All right, let's take a quick look at the UV editor just so you can see it and kind of understand what's going on. Come here, Maya, you nut. All right, there's Maya. Actually, let me do let's look at a cylinder. All right, here's my cylinder. If I want to see the UV layout of my polygon geometry, I go to UV, my main menu item UV, and I choose the UV editor. All right. When it opens up, you will notice that it is an orthographic window. So it navigates like an orthographic window, just like front, side, top. And we can move around within the UV editor as such, no tumbling obviously, but we can do the other things, track dolly, zoom in, zoom out. You'll notice that the UV editor also has its own little menu and tools because there's really fun stuff we can do to our UV shells, and we're going to talk about how to work on those. All right. You will also notice that my UVs will almost always appear in this quadrant. And if you look at this big, huge grid, yours might be mostly light gray, but just this corner is dark gray. This corner right here is called the 0 to 1 space. And it's called 0 to 1 because in the very middle here at the origin, it's 0. And over here at the end of this quadrant, it's 1. 0 to 1 space. You might also be wondering, well, why did they go from 0 to 1? Why is it not 0 to 100? Well, between 0 and 1, there are infinite numbers. There's always a smaller number between 0 and 1. So you could make it 0 and a million. It doesn't make any difference. It's an arbitrary value to represent a space that is as big as we decide it is. Does that make sense? This could be 1 inch by 1 inch. I could also decide this is 1 mile by 1 mile. Arbitrary values. Does that make sense? Hell yeah on that?
Oh, yeah.
Okay. How are my digital friends doing, Brian? They still with us?
They are on top of it.
Awesome. Good, good, good. That's what, yeah, that's what I like to see. Terrific. All right. So again, when you select an object, you see that object's UV layout. Incidentally, in case you were wondering, when I selected the polygon cylinder, again, nothing selected, nothing in the 0 to 1. If I select the object, I see the object's layout, right? This is the default layout for a cylinder. Something to be aware of. All polygon objects have a default layout, one that's built right in as soon as they were born. It's usually very, very bad. We have to fix it. Does that make sense? Just because it makes sense to Maya doesn't mean it makes sense to us. And usually the default layout is very poor and we have to fix it. So just so you know, that's what's going on there and why it happens to look like it does. And it's also very pushy. Every time I try to close it, it wants to jump back up. Me! Attention hog. All right, let's get back to this stuff. UV shells. Let's talk about UV mapping. Now, if you guys recall, the two things we talked about in terms of important in a map were what? Understandability, right? Mutual understanding of what that map is showing me. With a map, it's person-to-person communication. With Maya, it's you and Maya understanding what you're looking at. So everybody knows what we're looking at in terms of placement of texture. What was the other thing? Where the seams go, critically important because, again, what do I need this map to do dictates where I put the seams. But the other thing that maps are critically important for are accuracy. So you know how accurate the map is. Because if it's not accurate, it's a useless map. With UV mapping, if your UV shells are inaccurately laid out, also useless. Does that make sense? So understandability, accuracy.
So I just made a connection.
Excellent. I thought I saw a light bulb over there.
It's real similar to making a Minecraft game.
Real similar to making a Minecraft
It
game.
is actually.
It's, you know, I think it is. If I'm thinking about how that process works properly.
The map for making a Minecraft game that you have to color yourself is the same as a flattened and unfolded version of the Minecraft character.
Excellent. Yep, I kind of thought that's how that worked. Not that I had seen that process, but my understanding is that's the way that works.
It's also very similar to our assignment from Mark 1, where everything is Mark 1, our assignment to make the paper dolls.
Yes.
We have to color ourselves. That's UV mapping. That's UV mapping done that really rudimentary and simplistic way, but it's
Exactly. Do you think that that's a coincidence?
They obviously find it. Yeah, we all talk.
They told us that y'all yelled at them because
No, I don't yell at anybody. Seriously.
that's just what they told us.
Yeah, no, not at all. But we did get together and talk about what you guys struggle with the most. And across the boards, it was UV mapping. People said they have the hardest time with UV mapping. Even classes afterward, they have trouble with UV mapping. So I said, well, what is it we can do on your end? Because I don't have any room. I can't put anything else in. And they said, well, we've got this idea for an assignment we want to do. And I was like, I love that assignment. Please put that in there. That's a terrific idea. I think Holly came up with that one. Love that one. Love that one. Because that paper doll assignment is UV mapping on a very simplistic scale, but that's what it's doing. Absolutely. So we talked about maps have to be mutually understood, seams in the right place, and we have to have accuracy of the layout. Now, in terms of a map, you know, we have cartographers draw them up. We use all kinds of instrumentation to make sure that they're accurate. We measure to the nth degree to make sure we're right on the money with that kind of thing. Because if a map is not accurate, you can get lost. With textures, if your map is not accurate, you get distortion. Your textures look terrible. Now, what we have to do is test how accurate our UV layout is. Now, when it comes to that UV layout, what we're going to do is what you're seeing here. We're going to apply a test texture to our geometry. And we're going to use a checker pattern, because a checker pattern is composed of a bunch of little squares. And squares are, and I hate this word perfect, but squares are perfect. So if I apply a checker pattern to a piece of geometry, I can see how accurately my UV shells are laid out by the quality of the squares I'm seeing. Does that make sense? It's a test. So if I apply a checker pattern to my geometry, you'll notice I see a bunch of happy squares neatly formed. That's good layout. Does that make sense? Okay, so that's confirmation, good layout. Something to note, each piece, the squares are the same size. Does that make sense? For this class, you want every piece of the same object to have the same size squares. That's a question of resolution. Okay, they have to have the same size squares. In other instances, that's not the case. This class, they've got to be the same size. Does that make sense? Important distinction. With two different objects, they don't have to have the same size squares. Does that make sense? If I've got the beer bottle and my Lego man, they might have different size squares, but every piece on my Lego man will have the same size squares. Does that make sense? Yeah. Okay, because these are the things we're grading on. So this is a big ticket item. Same size squares throughout. Now, show me an example of inaccurate layout. You see on his arm here, up here towards the elbow? Do you see how that's not a perfect square? That's not a perfect square. There's a little bit of distortion going on there. Does that make sense? That's what happens when you don't have an accurate layout. You start to see strange shapes in your geometry, right? When you put the checker pattern on there, distortion. It's obvious when it's there. So here's the question. Is that distortion within acceptable limits, yes or no? Well, it does have to do with the edge flow, because the UV map is a layout of your edge flow, basically flat. Another reason why we try to have great efficient edge flow, because it's going to distort a little bit. So here's where you have to ask yourself, when you look at my character, the front of my shirt, there's a pattern on there. If there's distortion, will I see it?
Yes.
Yes, it will distort the pattern. On my arm, is there a pattern there?
No.
Just orange. So if it's a little distorted here, is that going to affect me as much? No. So just like the idea that we put the seams where the water goes because the water's not as important. Does that make sense? Because I got a pattern here, that's got to look good or it will show up. So when I look at my squares, wherever there's a pattern, I did the best I could to make that look good. Does that make sense? Arm, a little bit more flexibility. If I had a pattern on my arm, I might have to try a little harder to get that to improve, or realize that that's the best it's going to get and I have to live with it. Does that make sense? Okay, these are all really important concepts for UV mapping. Let's talk about that checkerboard thing again. All right, so we're going to discuss the process for applying a checker pattern to a piece of geometry so that we can determine the quality of the layout. These are the steps for the application of the checker pattern to test the geometry for the quality of its UV layout. All right. And you will find it surprisingly similar to other things that you've done. I'm going to make a sphere. There we go. Now, really quickly, in terms of components, right mouse button, vertices, edges, and faces. These are the primary modeling components. We've talked about these guys, right? Okay. Now, in terms of UVs, they're in that same menu set. UVs are another component, but they're not modeling components. They're more having to do with the texturing process. When you select the UVs, you notice that they're kind of brownish dots that occupy the same space as the vertices. But when you select these, they turn green, not yellow. So from brown, they turn green versus vertices, which are pinkish purple to yellow, right? Now, in terms of default layouts in Maya. Spheres have default layouts, of course. All polygon geometry has a default, but it's typically not accurate. How do I get to the UV editor? UV editor. So here we are in the UV editor. Here's my object. This is what Maya looks like, or what Maya thinks it looks like if I laid it out flat. If I took this sphere and laid it out flat, Maya thinks it looks like that. Not too bad.
But it's way bigger than one-to-one though.
Well, we got some issues, right? There's a couple of things that are not right. Now, we don't know that much about UV mapping yet. We haven't even gone into the process, but we've kind of discussed how it works a little bit. What do you see when you look at this layout that tells you that can't be that? That can't be accurate. There's got to be something wrong with this. This doesn't quite. If you took all the faces of this, somehow it makes a square. That's kind of weird to think, right? Because it's packing the 0 to 1. What else do you think?
The faces on the sphere are way bigger, and you don't really know which word is like making sense on the UV map.
So I've got two problems here that you're talking about. Number one, where the heck am I? That doesn't make any sense to me. I can't look at that and decide, oh yeah, that's that. You know what I mean? So mutual understanding, not there. So we've already failed on that. Number two, the shapes of the faces, right? These are faces. They represent these faces. These are all perfect squares. Are those all perfect squares? No. Some of those faces are rectangles. Does that make sense? So if I have a texture, a square of information, and I'm trying to fit it into a rectangle, what am I going to have to do? I'm going to have to stretch the square big enough to fit in a rectangular space. And if I have to stretch the square to fit, what's going to happen to my texture? It's going to be distorted, right? It's like wearing a t-shirt that's too small. Everything's going to get stretched out. Things aren't going to look right. Does that make sense? Okay, so this can't be right. And as far as the mutual understanding, let's say I want to put a texture of the earth on here, right? Spinning globe, right? And I want to put North America right up here where I imagine North America is, right? Where is that over here? It's over there by the thing, right? I have no way of knowing. Now it's true, if I wanted to, I could go into my UV settings here and say, okay, here's North America. It's going to be right here, right? There's California, Canada, there's Florida. Oh, there it is, over there. I would have never known that that's where that is. Does that make sense? So mutual understanding between Maya and me? Nope. Accuracy? Nope. Does that make sense? Poor UV layout, so I'm going to have to fix that. That wouldn't change it. It would still be subdivided, and we would end up with, well, subdivision gives you more coordinates to work with, kind of like going from hours to minutes and seconds of longitude and latitude. Does that make sense? Finer level of detail, but that's not necessarily going to yield a more accurate texture layout, because there's a point where it's so dense that it's actually a problem, because you can get fewer pixels into each face. I'm sorry, can you have a perfect UV layout? I hate the word perfect, but what I'd say is we always go for the best we can possibly get. Because the reality of the situation is some very complex objects are extremely difficult to lay out flat. And that's just the reality of the object. Does that make sense, Lowell? Yeah. Okay, so we do the best we can. And to that end, what I would say is when you're UV mapping, it's not process A, process B, process C, I'm done. UV mapping is a journey. It's an exploration. Let me try this way. No, that's not giving me good layout. Let me try this way. Oh, that's pretty good. Let me try just this though. Oh, that's so much better. Does that make sense? It's not ABC, it's done. You have to find your way to a good layout. It's almost like a puzzle or a riddle you have to figure out. Make sense a little bit? Okay. So obviously mutual understanding, no. Accuracy, definitely not. Now, looking at a sphere and looking at its default layout, it's pretty obvious that it's not accurate, right? You guys figured that out in no time at all. So how do I figure it out if I've got like a 10,000 polygon dragon? What looks good and what doesn't? Well, here's where that checker pattern comes into play. I don't have to figure it out. The checkers will tell me. If I see happy squares, good layout. If I see distorted squares, bad layout. Does that make sense? Okay, so these are the steps for the application of a checker pattern to determine the quality of the UV layout. How good is the layout? I'm going to apply a test pattern and find out. So, step one, we need to create a new material. All right, if you guys remember from the bus, when we're creating materials, we go to window. Yes, you're right. Rendering editors hypershade, right? Because that's where materials are housed. So first I have to get a new material. And as you guys recall, in terms of creating new materials, we work with Lamberts in this class to avoid issue. So what I'm going to do is go to the create window and go down to Lambert and just click on it and make a new one. Because we always play with new materials. We don't play with the defaults. We leave those guys alone, but we can play with these new ones. Now, with this new material, I'm going to name it, because of course we always want to name this stuff. Checker material. Okay. Now, created the new material. Step two, apply the checker pattern. Now, before, when we wanted to change the color of a material or what it looked like, we went to the color channel, right? We clicked on this, we opened up the color history, and we picked out whatever color we wanted. But I'm not applying a color. I want to apply a texture. I want to take an image and put it on the geometry, right? So I'm going to do something a little bit different. I'm going to go to the color channel, because that has to do with what it looks like on its surface. But what I'm going to do is go all the way to the end of the color channel to this little checker box. I'd like you guys to think of those checker boxes as almost like a power strip with a bunch of plugs in it, right? I can plug stuff into the different strips to power my various electronic devices. Each one of these little checker boxes allows me to connect things to each other. So I'm going to go to the checker box at the end and click on it with the left mouse button. This opens up the Create Render Node window. The Create Render Node window has all kinds of fun stuff to deal with texturing. But the one we're interested in right now, number 2, checker. You see that one? Second one from the top. So all we do is we click on checker, boop, and it creates this checker pattern. And you can see my little test sample. This is my checker material, and it's got a nice little checker on there. And I can see it in terms of what it's doing there. Does that make sense? Black and white checkers. But here's the thing, a little bit of advice, me to you. Take it or leave it, it's entirely up to you. When I take a look at my geometry's UV layout, right? If I'm in the UV editor, what color is my shell? These lines, they're white, right? So if I've got a black and white checker and I'm looking at a white shell on top of it, am I going to be able to see that very easily? No. Advice me to you, change it to black and something else for your checker color. Does that make sense? So when you first apply that checker, you have the ability to change that color. So instead of black and white, I'm going to click on the white field with my left mouse button and choose another color. Anything is fine. But the white shell will show up better against a color. Make sense? Hell yeah? Okay, good. Now, next step, apply the material to the object that you want to test. How do I apply a material to an object? Middle mouse button, drag.
You can just select your object from the object mode, right click your texture, go up and assign.
I can, 2 different ways that I've shown you. There's more, but there's 2 different ways. Hold down the middle mouse button, drag and drop, or select the object, hold down the right mouse button, assign material to selection. Either of those is fine. And it will assign this material to that object. Now before, when we assigned a material and it was a different color, we saw it instantly, right? We don't see it right now because we didn't assign a color to the material. We assigned a texture to the material. Does that make sense? This is genuine texturing. So in terms of seeing a texture, 4 is wireframe mode, right? 5 is shaded mode. We have another mode, which is show me my model with a texture on it if there is one, and that's 6. So if you press 6 on your keyboard, you will actually see the texture, right? Now, I applied happy little squares. If I look in my UV editor, right, and why wouldn't I? All the cool kids do it. If I look in my UV editor, I see perfect squares. But when I look at my geometry, what do I see? Rectangles. That's just confirming what we suspected all along. Does that make sense? Again, it's easy when you're dealing with simple polygon primitives. When you're dealing with something more complex, it's a lot harder. That's why we need those squares. They do the work for us. Does that make sense? So obviously, this is not good layout because I see rectangles, not squares, because that's what I should see. I see rectangles, therefore bad. Also, if you look at the top of this thing, are those squares? Nope. So clearly not a good layout. Does that make sense? Okay, so how do we find out if we have accuracy in our layout? We put a checker pattern on it. In terms of commonality, both Maya and I understanding, that's pretty straightforward. If you look at your UV shell and you can tell what everything is, you get it. And Maya gets it too. Does that make sense? Okay, so clearly in this instance, both of those things, those requirements have not been met. This equals poor UV layout. Therefore, we have to map it, remap it. Does that make sense? Anybody lost on that? Good? Okay, how my digital friends doing?
Maya doesn't have a brain. Poor scarecrow Maya.
Maya, well, I would say Maya is brilliant with math, brilliant with numbers, not very creative, and could care less what you're doing. So I would say Maya is extremely insensitive.
Like most things with a high intelligence art.
Exactly. All the smarties, they don't like anybody else. But that's the issue. Again, Maya is very good with math, but not an artistic machine, and not very creative, and not very understanding. You know, and thank goodness for that, because the day Maya can build its own stuff, none of us have a job. So thank goodness Maya doesn't do its own work yet. All right. So hopefully that will not ever be a thing, but it's possible. All right, so at this point, we've determined UV layout is bad. Any questions on any of that stuff so far? Because we're going to move into some more wacky stuff. No, oh yeah. Create materials, applying checker patterns. We're all good? All right, let's press on. So next issue, UV layout is bad. What do I do about it other than cry? We remap it. Yes, go ahead. You can change the scale of the checker pattern. But what we're going to find out is we want it to all be the same and it's relative object to object. The key is making sure that all the checkers are the same size on the same object. And we're going to talk about how to make sure that happens. Yes?
If by any chance I mess up my UV shell really badly, is there a way to just put a button %?
Well, here's the cool thing, and this is about what we're about to delve into. When it comes to UV mapping, we are not breaking anything, we're not destroying anything, we're just going to remap it. Much like the idea that I can have a map that I got at a gas station of Florida, right? I can have a map so I can find my way. And if I take that map and tear it in half, I'm not actually tearing Florida in half, it's just paper. UV shells are the same. I can do whatever I want to them. It has nothing to do with the actual object. UVs do not accept or affect shape and form. They're just maps.
If anything, I could just delete that picture and add another one.
You can just make another one. You can remap it, almost like redraw it. Imagine like a map that you draw with dry erase. This one's no good, do it again. And Maya will accept whichever one you decide is the final. Does that make sense?
Yes.
Okay. So, no good, time to fix it. What do? We use UV mapping tools. Now, in terms of UV mapping tools, there are two tools that we use almost exclusively, really. And these two tools actually bear striking resemblance to tools we use all the time, and that's why I draw this parallel. When we take pictures, right, when I take a picture of somebody or something, I am taking a 3D idea, the universe around me, right, and I'm turning it into a 2D thing, an image. I can print it out. Does that make sense? Photographs basically take 3D and turn it into 2D, okay? One of the UV mapping tools we use works on the same principle. I'm literally taking pictures of my geometry and creating flat images of them. Does that make sense? That's the planar mapping tool. Planar mapping because it maps things in planes. It's basically like taking a picture. The concept of the 3D world as we understand it, turning it into a 2D image that we can print out and give to a friend. Planar mapping tool. We also have available to us another tool. Instead of taking flat pictures though, this tool scans in a cylindrical pattern. And it works a lot like an MRI. How many of you guys have ever had an MRI? Anybody in here? Just checking. Yeah, this is probably the lowest number I've ever seen. Well, I've had a couple of them. They're miserable. If you've ever had one, they're awful experience. Basically what they do is they take all your stuff and they put you in a drafty gown, which is way uncomfortable and extremely unflattering. And then they lay you down on a bed and they shove you into this tube like you're a cannonball or something. And you're inside this tube and it's so tight in there, it's really uncomfortable. And only your feet are sticking out or less. And then that's when they talk to you. They're like, how's it going in there? You're like, this is great. I feel like I was just buried. But basically you're inside this machine, laying down flat. And what it is an enormous magnet. And what this thing does is it rotates around your body, kind of like a scanner, flatbed scanner. But it's not scanning flat, it's scanning around. And what it's doing is it's using these super powerful magnets. And these magnets are pulling on the molecules of your being. And then after the magnet passes, the molecules get let go. And what it's doing is it's measuring the movement and the distances, and it generates a flat image based on that. So what you're doing is you're taking a 3D object and you're scanning it in a cylindrical pattern and creating a flat image from that. Okay? So, planar mapping tool makes flat images from taking flat pictures. You would use it on flat-ish surfaces. The cylindrical mapping tool scans things in a cylindrical pattern. So things that are cylindrical in nature, you would map with the cylindrical mapping tool. Telephone poles, pipes, arms. Does that make sense? Things that are basically cylindrical in shape. If you had to use one, I would planar everything. And I tend to planar way more often than cylindrical map. I've had a lot more success with that. It's an interesting question. Probably the first time anybody ever asked me that. But are there more mapping tools? Absolutely. These two are the ones by far you will use the most, and planar more than cylindrical. All right. Now, in terms of what these tools look like, this is the planar mapping tool, and this is the cylindrical mapping tool. The geometry is just relative to the surface you would be mapping. But the tool itself is this thing that's floating just above it. It's got manipulators on it so that you can change the size of the tool. This is the planar mapping tool. There's also a cute little red T in the corner that if you click on it, you can actually change the angle at which you are mapping. So if you're planar mapping or taking the picture of something that's at an angle, you can actually adjust the camera to take a picture at an angle as well. thereby increasing the accuracy of the image you just took.
So that means that the tool doesn't actually move around like a mesh, like an object. So
It can be moved and manipulated, but really it moves to where you choose to map. And that will make more sense when I show you how it works. But you don't kind of create the tool and bring it into play and go, okay, let's get a shot over here. Like literally you're saying, take a picture of these faces. So the tool appears over whatever it is you're taking a picture of. Does that make a little bit more?
Yeah.
Okay. Now, cylindrical mapping tool, same thing. I've got these manipulators that I can grab hold of to change the way that tool works. And I've also got another one of those little red T's that I can click on to change the angle that the tool is riding on, because not everything is up and down, right? This cylinder is up and down. Therefore, the tool is up and down, right? In my previous example of the MRI, am I standing up and down or am I laying down? Laying down. So if I do an MRI, I'm not going to scan me this way. I have to scan me this way because I'm lying down. Does that make sense? The tool has to follow the shape and form of the object. All right. You guys want to see these guys in action? Planar mapping tool, cylindrical mapping tool. We're going to do them both. All right, so you see we got the activity file image, so that means we're doing an activity file. So I've got to set my project to my activity files. File open scene, and I'm going to get my UV mapping activity. All right, and you will see that you've got three objects, a plane, a cube, and a cylinder. Gesundheit. Before we get into that, is there anything my digital friends want to ask me about the planar mapping tool or cylindrical mapping tool? Is there anything you feel you have a question about? I meant to ask you that before I opened up the activity. Okay. Okay, good. All right, so we've got these three objects, right? Three different basic shapes. We're going to start with the left and go to the right. The plane, geometry plane. Off the top of your head, which tool do you think you would use to map the plane? Planar for sure, because it is a plane. Does that make sense? Kind of a giveaway. And the cylindrical, everything else. No! All right, so in terms of the mapping, we know step one is the application of the test pattern, right? That's the first thing we do. Who can tell me the steps to the test pattern? What do we do first? Windows, rendering editors, Hypershade. We go to the create section and we go to Lambert. And incidentally, if you're missing a window, don't panic. Your Hypershade may be laid out differently than mine. In fact, you might open the Hypershade and it's completely empty. Just go to window and all the windows are listed there. And you just click on it and that window will appear. So you have all the windows you need. They're there. Just go get them if you don't see them. That's in the Hypershade. So in the Hypershade, I'm creating another material, so I click Lambert. All right, and as I said, we always name stuff because it gets away from you quickly if you don't. So this is my checker material. And I only have to create it and name it once for each scene because I can use the same material for all of my objects if I want. Does that make sense? Okay, so I did step one, I created a new material. What's the next step? Go to the color channel, go all the way to the right to the checker box, click on it, boop, and it opens up the create render node window. Which node do I want? The checker one, right? So create the checker. And again, as I said, good idea to change the white to a different color. Purple and black or pinkish purple and black is fine. So now, what do? I've applied the checker pattern. I can see it on my material. Apply it to my polygon. Again, middle mouse button, drag and drop. or select the polygon, right mouse button, assign to selection. Any of those are fine. But when I'm looking at it, I don't see my checker pattern. ¿Qué pasó?
It's already patterned good.
It's good. Yeah, everything's fine. What's wrong? Why do I not see?
Press it.
Gotta press 6. That is critical. When I press 6, I see the checker pattern. All right. Now, if I go to my, over here, UV, if I go to my UV editor, I can see checker pattern. It should be happy squares, right? This shape right here is what Maya thinks the UV layout would look like if I laid this object out flat. Hint, hint, it is flat already. So obviously that's not good. And I can see that because when I look at this piece of geometry, there is a tremendous amount of distortion, right? This crazy zigzag pattern is not a checker pattern. Therefore, what do we deduce? The UV shell's messed up, right? It's not good because I should see happy squares and I don't. Does that make sense? Is everybody at this point? We're good? You got this crazy zigzag? I have to be fair to Maya. I actually made these UVs worse than they were on purpose just to make it more obvious. Does that make sense? I did that a little bit. But now that we've determined our UV layout is poor, now we move forward with UV mapping. Now we've determined already planar mapping tool is a way to go because this is a geometry plane. So these are the steps for UV mapping or the creation of UV shells. Step 1, select the face or faces you wish to map. You are literally telling Maya, I want to map these faces, because you might not want to map all the faces at once. You might want to map just this or map that. Create the shells as you wish. So luckily, this piece of geometry only has one face, so it's pretty obvious. I'm just going to select that one face. Now, here's where we have to do a little bit of thinking. If I want to take a picture of that face, right, just like a camera, what axis would I use to take that picture? Which would be the ideal one? What do you think? There's X, Y, and Z in there. Y? How many of you guys think Y? Oh, so you could look from the top. How many of you guys think X?
Depends on which, like, where is your camera? Where is this?
The camera will take the picture on the axis you ask for. So if you ask for a picture in Y, it's going to take a picture like this. If you ask for a picture in X, it's going to take a picture like this. And if you ask for a picture in Z, it's going to take a picture like this. So the axis you choose is literally the axis the camera is on. So if I want to take a picture of that plane, that face, what axis do you think I would choose? What do you guys think? Y axis. Okay, a couple of votes for Y. I'm going to choose X just so we can see what happens. In terms of UV mapping, again, select the face or faces you wish to map. Then, under your UV menu set, go to your planar mapping tool and go to the options box, because this is where you tell it where and how to take the picture. So when I open up the options box, it asks, what axis do you want to take the picture from? And I'm going to leave it at X, because you can change it to whatever you want. I'm going to change it to X, right? And I hit project. All right. Now, do I see happy squares there? I don't. But if I look at my UV editor, it should be happy squares, but I don't see any because I chose the wrong axis. Poor layout after mapping means you chose the wrong axis. So instead, I'm going to grab that. I'm going to do my planar mapping tool, but this time I'm going to switch it to Y axis. And I'm going to hit apply. Boop. And now I see happy little squares, right? And if you look, you can see the tool floating just above the geometry, right? And I can adjust the tool, right? Is that good layout? Is that good layout? It looks all mashed up, right? How about that? See that? Nice, happy little squares. Now again, if I want to change the angle that I take the picture on, I can click this little red T, which gives me a tool that kind of looks like the extrude tool. And I can click this little circle because that's the rotation capacity. If I click on that, I have the ability to rotate the tool to change the angle that I take the picture at. But it's actually good where it is, so I can leave it alone. And if you look inside my UV editor, you can see I've created a shell. And when I'm UV mapping, what I do is after I create a shell, I drag it out of the 0 to 1 space. I move it out of there because most objects are made of more than one face, and I have to continue to map, and it's actually helpful to pull the shells out and pull them to the side because once the 0 to 1 is empty, you know you're done. Everything's been mapped. If you just keep creating UV shells, they will dogpile on top of each other. Very simple. When I created the shell, when I first created it, you'll see the shell is in there and there's like a manipulator. All I have to do is grab that manipulator and move it. All right? Now, something to think about. This UV shell is composed of UVs, right? It's basically points that help to define this shape. I can go into UV mode and I can grab this shell and then using my move tool, I can move it around. Okay? Look at my geometry, right? Watch me move the shell. Yes? It should show up here when you select the geometry in object mode. Then Maya has exploded. Every once in a while, some wacky stuff happens. Have you restarted recently? Oh, okay. You may need to restart it again, but typically you should see whatever texture you put in there. I have seen instances where that didn't happen, but that doesn't affect your process. No, it doesn't affect anything. But what I want to show you is watch what happens because I can select a single UV just like I can select a single vertice. Watch what happens when I move just one UV. Does that strike you as a good thing or a bad thing? Bad, right? Because the problem is if I change the relative proportions of my shell, it will distort my texture. When my squares look good, that means that this shell here most accurately represents this piece of geometry. So if I want to move a UV shell, I want to make sure I grab all of them, all of the UVs, and move them together. Does that make sense? Yes?
I could have manually, like created that same like square, like before you use the planner tool.
Mm-hmm.
I could have moved the vertices.
You could have, but what we're talking about, this is a simple square. If you've got a 10,000 polygon dragon, not going to happen in this lifetime. Does that make sense? Yeah. Oh, I would honestly, if I walked into an office and they said, here's what I want you to do, grab these UVs one at a time and move them until the texture looks good on this thing. Thank you very much. I enjoyed meeting you all. I will be on my way. I'm not doing that. Again, could you, at its default, with something that simple, just move it around? Yeah, but anytime you introduce a human, there is a margin of error that is much greater than that of a machine, which uses crazy math to calculate this stuff. In fact, you know what? I still don't have my dry erase marker. I forgot it again. All right, but what I was going to tell you guys in terms of the math that Maya does, it does math. It calculates out mathematically everything that you do 16 spaces to the right of the decimal point in terms of accuracy. 16. Yeah, crazy accurate math. So, you know, does Maya act kind of funny sometimes? Does weird stuff happen every once in a while? Yeah, because the math that we're asking it to do is ridiculous. And it's got to work with the parameters of whatever laptop we have it on. You know what I mean? You put Maya on NASA's supercomputers, I bet it runs with a lot less issue. But, you know, it works with what it's got resources wise. But the math we ask it to do, the level of accuracy we demand from it is crazy. So yeah, sometimes you get some hiccups, but that's what we're asking for. Does that make sense? Okay. So again, much easier to move this thing around with a whole shell. Now, sometimes people will tell me, I've got a bunch of shells on top of each other and I'm trying to separate them because they will pile on each other sometimes, especially if you forget to clear the 0 to 1 with each shell you make. So what you need to do is select a single UV and then hold down, if you look on your keyboard, the command key, which is just to the left or right of the space bar, and the right mouse button, and you will see 2 UV shell as an option. And that will allow you to select the entire shell from just selecting one. And again, that ensures that you move the shell as a single unit and not as individuals and distort things. Does that make sense? It helps to maintain the perfection, if you will. Okay. All right. Time to do the next object. Here's my cube. Here's what Maya thinks my cube looks like laid out flat. What do you think? Nasty, definitely bad layout. Again, to be fair to Maya, I made it look a whole lot worse. But we can test it, we can check it, right? Pun intended. What do I do to make sure this layout is bad? I suspect it, but what can I do? Assign the material, right? So I go back to boop, the hypershade, and I apply the material. And it is confirmed that yes, in fact, this is bad layout because I don't see happy squares. Does that make sense? Now, what I like about UV mapping is that the process is repetitive. We're going to do the same thing again and again. So this will help you remember it. But again, it's a journey. We have to find our way to good layout. So memorize the process, but realize it's not ABC, it's done. It's an adventure. We've got to figure out a good layout because no two objects will lay out the same. All right, so time to map this object. It is composed of many faces. So, Gesundheit. That is the second cutest sneeze I've ever heard. There was one cuter. I think that was last year. It was really close though. It was really close. But the other one was a little bit higher. It sounded kind of like Minnie Mouse. So, all right. So here we go. Time to map this cube. If you recall from the mapping process, first we select the face or faces we wish to map. So I grab one of the faces on this cube. Now, what tool do you think we're going to use on a cube? Planar mapping tool. It is a series of planes, so that makes sense. So, next question. If I'm going to take a picture of the face I have selected right now, what axis do I choose? What's that? You could choose all the axes. No, you can't. You got to pick one. But, so here we go. I grab that face. I go to UV. I go to the planar mapping tool. And I choose the y-axis because if I want to take a picture of this face, I'm definitely looking down the y-axis. So I hit the apply. And you will see the tool hovering just above the piece of geometry. And if you look, I've created a shell. I drag it out of the 0 to 1. You'll notice there's still something in the 0 to 1. These are the faces I haven't mapped yet. Why do I drag stuff out of the 0 to 1? So that I know when I'm done. Because once all the shells are out, I know I'm finished. Does that make sense? Just neatness. So I've mapped this face. I see happy squares, so I know I'm good. So let's do another face. I grab this face. Get my move tool out. What axis do I take this picture on if I want to get a picture of this face? Z-axis. Again, I'm looking right down the Z-axis, so therefore it must be Z. UV, planar map. I choose the Z-axis. I hit the apply. I create another shell. I drag it out of the 0 to 1. And again, I'm looking at happy squares there. All right. I want to take a picture of this side of my cube. What axis do I take that picture on? X. Again, I want to do X because I'm looking right down the X-axis. So, UV, planar, I choose X, apply it. Again, I've created another shell, so I drag it out of the 0 to 1. All right, here's where it gets fun. If I want to take a picture of this face, what axis do I want to take that picture on? Ooh. We got a little contention here because we do want to take it on X and we are on the negative side of X, right? Because the arrow is over here. So if we go to our planar mapping tool, there's not a negative capacity.
It doesn't matter where on the X-axis you take it,
So I got to take it in the X because that's the only one I've got, right?
but you can move it around and still put it on that thing.
Yep, still in the X-axis. So I got that picture. And again, I see happy squares, so that confirms I'm doing the right thing, right? How about this guy? What do you guys think? What axis? Z, absolutely. UV planar. Take it Z axis. I create a new shell. I drag it out. There's still something in here, so I know I'm not done. Oh yeah, this guy right here. Right? What axis do I take this picture in? Y-axis, absolutely. Again, it's down here. You would think negative Y, but there's not a negative Y option. So I've got to go with the Y-axis. All right, created another cube. Right, happy, happy. Now, time to do this guy. Yes, go ahead.
If the faces are on the same axis, can it's like multiple faces?
You can, but what you have to be careful of is that those shells will be on top of each other when you create them.
And move, but I can move them separately.
Yes, you can, but you have to separate them from each other, which gets trickier. Which, again, for beginners, I typically recommend just shoot them one at a time until you're really comfortable with the process, and then you will find shortcuts and workarounds to speed it up. But just for simplicity's sake, it's a little bit easier to do it that way. All right, so now I want to map this piece of geometry. What are the steps? Who can tell me? What are the steps for this? Yes? Apply my checker pattern. Yes? Yeah? Hey guys, hold on one second. There's a great question about to be born. Mm-hmm. Yep, the 0 to 1 space. Yep.
And it's okay for the shells to be outside of that pattern?
For right now, yes. Because right now what we're doing is we're figuring out quality of layout, we're creating shells, and we want to make sure we map the whole object. We will get back to that though next class, and no, we're going to talk about that because when we're all done, all of our shells are going to go back into the 0 to 1 space. That way we can make sure that our textures align properly. Does that make sense? Because you have to think of the 0 to 1 space as like a frame. I want everything inside my picture. Everything fits in there. I work on it out here in the workspace. Kind of like if you're on your desktop, right? You're creating a piece of artwork or whatever. You've got stuff all over the place. You're cutting, you're gluing, you're drawing. Everything is all everywhere. But when it's all done, it has to fit into this frame that you're going to put on the wall. And that's what the 0 to 1 space is. It's that special frame for putting things in. Does that make sense? So when we're all done, we are going back to that. But at this stage, what I want to see is that you can recognize bad layout and you know how to remap. Does that make sense? So baby steps.
So, like, whenever you actually move the shelves, like, just moving it somewhere else on the pallet?
Basically, yeah, it's just moving it to elsewhere.
So 0 to 1 is the canvas, the rest is the pallet.
Kind of like the palette or kind of like your desktop or whatever you want to call it, the work area. It doesn't really matter what happens out here. It's when it gets back in to the frame, the 0 to 1 space. That's what matters. Does that make sense?
Yeah.
Okay, and that's in terms of trying to set up our color map, our texture, right where we want it to go.
They're not all layered together.
Yep. All right, so time to do the cylinder, right? Again, the process, thankfully, is repetitive. Window, rendering editors, hypershade. I open up the hypershade. I've already got a really cool texture. I apply it. Yeah, and you can see, oh, this isn't good. Now, here's where it gets a little bit tricky. All right, number one, I want to map these faces here because you see I've got a bunch of faces here, I got a bunch of faces here, and I got a bunch of faces here. Now, it's true, I could, and I'll go to wireframe just because it's easier to demonstrate. I could hold Shift and select all these faces. That's really slow. All right, there's another way to select just those faces. What I can do is use my Paint Select tool. And the Paint Select tool is a really cool tool. When you select it, you'll see it looks kind of like a red circle. And basically that red circle, those are your bristles. This is a brush you're painting with. And if you hold down the B key as in boy and the middle mouse button and drag left and right, you can make that brush big, smaller as you need to. All right? And what I'm going to do is paint and literally select the faces I want in one quick swoop. All right? So I've selected the faces that I want to map because oftentimes you're mapping more than one face. So I've selected the faces I want to map. I don't know. What do you think?
Well, you can use the black
How's that going? Is that better? My computer just decided to mute me.
Mutiny on a computer.
That's right, Mr. Christian.
Yes, much better.
Yay! All right. So panicky not. If there was, hopefully that audio dropout was a very brief one, but feel free to watch the previous month's lecture if you think you're missing something. And of course, always go to the Google Hangout because Brian is lonely in there. So go hang out with him and he'll tell you anything you missed. All right, so the vote is this the planar map or the cylindrical mapping tool? I have 2 votes for planar. Is there anybody who believes it's the cylindrical mapping tool? Yeah, just so you can be the other side. Good for you. Can't have everybody voting for the same thing. The answer is we are talking about the planar mapping tool again. Now, it's true, the shape we are mapping is round, and that's what makes it confusing, but it is flat. Therefore, planar mapping tool. Does that make sense? So your logic is correct. Now, in terms of the axis, what axis are we talking about? X-axis. So we go to UV, planar mapping tool. We choose Z and we map it. All right. Now, oh, I'm sorry. My bad. I want X and map it. Map it good. And you see I've got a nice little circle here and it looks like that. Again, mutual understanding being a big ticket item. And I see happy little squares. So I'm going to do the same thing on this side. Right, face mode. I'm going to grab my paint select tool, paint the faces I want. And then what axis do I take this picture on? X also.
But I have a question.
Yeah, go ahead.
So if the faces are both on the same axis, what would prevent you from mapping them at the same time?
Well, and that question did come up earlier. What happens if you map them at the same time? And the truth of the matter is, you could select all the faces on one side of the cylinder and all the faces on the other side of the cylinder and map them both at the same time, but the shells would be directly on top of each other and you might not realize they were on top of each other. Does that make sense? And just for beginners, I think it's easier to just imagine them as separate entities. But later, as you get more comfortable with this stuff and you feel like you have a strong understanding, oh, there's all kinds of stuff you can do to kind of make it a little bit faster, the process. But at this stage, just for simplicity's sake, I recommend just do a couple faces at a time and don't try to do too much because it can get away from you in a hurry. Yes?
I was just gonna ask if you want separate things about, so you have a different top texture and bottom texture.
Oh, you definitely would want it separate in particular for that reason. But in the instance of just their creation, would it matter? No, not really. But things that you have to think about is as you create shells, you noticed I grabbed the faces on the end to create the shells. As you create shells, based on what faces you have selected, they attach them to each other. Does that make sense? So sometimes you can create something you didn't really want, and then you'd have to do a little bit more work. But again, the idea is if you can see it in your head and you understand the unfolding of 3D space in your head, and I'm not talking about the movie Dune, it's easier to do that kind of thing. But as a beginner, it's kind of a lot to ask for. So I don't even want you guys to try to do that yet, but you will eventually be able to unfold objects in your head. And you don't even have to eat that crazy brown stuff to make it happen. And be the Kwisatz Haderach. Is he the Kwisatz Haderach? Nope, Jedi, straight up. All right, so we've created these 2 ends of the cylinder. Last series of faces through the middle. So what I'm going to do is go to face mode and I'm going to do a marquee selection of the middle, and that grabs all of the faces all the way around my cylinder. Now, interestingly enough, you can see there's some faces in here. I could go to face mode and just grab these faces because I know that these faces here are those faces there and those faces there are these faces here. Does that make sense? Doesn't matter. It's like all windows in Maya. They work together. They just show you different things. But just grab all the faces all the way through. I didn't select the ones on the ends because I already mapped those guys. So I just grabbed the guys in the middle. Now, Now what tool am I using? Now I'm using the cylindrical mapping tool because the object I'm mapping is a cylinder. Does that make sense? Could I use the planar? Yes, I could. I could absolutely use it, but then I wouldn't be showing you the other tool. So here's where we're going to use the cylindrical mapping tool because it is a cylinder. So with the faces selected, UV, and you'll see cylindrical mapping tool. It's right above the planar. Can't miss it. We run the cylindrical mapping tool, and I look at what it's doing, and which is very psychedelic. But is that what we want? Does that look good? No. And look at my shell. Look at that crazy looking thing. Does that look right? Is that what you imagine a cylinder would look like if I laid it out flat? Right? Imagine you took a paper towel, cardboard paper towel roll, and just cut it down one side and laid it out flat. It wouldn't look like that, right? So obviously something is amok. Let's take a look at the tool. Here's the tool, and you can see by looking at the tool, it is scanning in this direction. Does that make sense? It's scanning this way, as though my object were standing up. Is my object standing up? What's my object doing? It's laying on its back or on its side, right? So obviously I am scanning in the wrong axis, and that's why I have this terrible layout. So how do I fix that? I go get the little red T. You got to go find it, but it's in there. It's right here. Absolutely. So what I'm going to do is grab the circle, which gives me the rotate capacity, and then that's going to allow me to turn this thing. And what I want you to do is look over here in the 0 to 1 space. Watch what happens as I rotate this thing into the correct position. See the shell changing? Does that make sense? And I can even come in here and plug in 90 degrees and hit enter just to make sure that thing lines up right. Okay. All right. And now that I'm looking at my shell, right? Are those squares? What shape am I looking at? Rectangles. Are rectangles good or bad? It could be better. And depends is actually a good answer. It depends. So I'm looking at rectangles. I know my objective is squares, right? So here's where we have to ask ourselves some important questions. Here's my UV shell that I've created, right? And if I'm looking at my shell, I don't see squares in there, I see rectangles. So here's where I have to ask myself, if this was a piece of paper, right? You guys take a look up here. If this is a piece of paper, right, and I cut it out, do you think I would be able to wrap it all the way around that cylinder? Do you think it would fit? If you think about the spatial relationship. If I cut that out and stood it up on its side and tried to wrap it around that cylinder or that circle, do you think it would make it all the way around? Maybe not. It doesn't look like it. It's not very long, right? If you think about wrapping it, there would probably be a space there. All right? Another important thing to think about, if you look at my object, right? If you look at this thing, it looks kind of like a soup can, right? In terms of its proportions, like a Campbell soup can. And I'm not giving Campbell's a shout out for any particular reason, I just mentioned that. So in terms of this shape here, that probably wouldn't look like that proportionally. It's not accurate. But watch what happens when I grab this shell and I change its shape. I'm going to switch to my scale tool. if I squish it this way, is that getting better or worse? Everybody looking? This is important. Do you see this? Is it getting better or worse as I squish it? Okay, Gesundheit. Now watch if I squish it this way.
It's getting better, but it's getting bigger.
Ah, the squares are getting better, but bigger. And then there's too far, right? So I'm going to back it up to where I was looking at good looking squares. So now I've got good looking squares there. This looks pretty good in terms of what I'm seeing. But again, if I were to cut this out and try to wrap it around that cylinder, that really wouldn't give me a soup can. It would be more like a tuna fish can, right? It's too short. So let's take a look. Look at the squares on the side and look at the squares in the middle. Are they the same size?
Nope. They're not.
Do you guys see how these squares are smaller than those squares, right? These are smaller and there's more of them. On the side, they're bigger. They're all squares, so good shape. So I've achieved a good layout, but I've got a problem with my proportions. Okay? This shell is not proportionate to these shells. And I see that because the squares are different sizes. Does that make sense? Now, when I was talking about the squares and what they need to be, what did I tell you guys was important? They have to be the same size on the same object. So if this is my object and these squares are super small compared to those, what Maya is telling you is the proportions are off. These are not the right size relative to each other. They don't accurately represent that surface proportionally. In terms of the quality layout, pretty good, but proportionally, it's not. So here's how I'm going to make an adjustment. I can either make this shell bigger or smaller, or I can make these shells bigger or smaller. What do you guys want to do?
Make the circular faces small.
Make them smaller. Okay. Now, since these circles represent the ends of this shape, would you agree that they should be the same size?
Yes, both of them.
They should be the same size because they are the same size on this object, right? If I look at them in the side view, they are the same size on top of each other. So these need to be the same size. Okay? So what I'm going to do is grab them both. Because I don't want to grab just one of them. I want to grab them both because I want to change their size, but I want to change them together because they are the same size. So I get my scale tool out, and first I'm going to make the shells together bigger. What's happening to my squares? They get smaller. Do they still look like squares? Yeah, they're still squares, but they're getting smaller. Was that my goal? What did I want to do? I want to make them bigger. So I'm not going to make my shells bigger. I'm going to make them smaller. Now my squares are getting bigger. And what I'm going to try to do is get it to where the squares on the side are the same size as the squares on the end. Now I'm going to move this to line up a square here with a square there. And all I'm doing is moving and scaling. All right, I'm going to line up this square with that square. So I'm just going to move it into position using my move tool. And then I'm going to use my scale tool and adjust the scale until the squares are of similar size. Does that make sense? When the squares on the side are the same size as the squares on the front or either end, then I know the proportions are correct relative to each other. Does that make sense? Now it matches. Now if I take a look at these two circles, right, and I compare them to this rectangle, now that rectangle would wrap all the way around those circles. Does that make sense? I could definitely see that making it all the way around now. Before, I didn't think it would make it. But if I cut this out now, it's going to wrap around just fine. Does that make sense? Hell yeah? Okay, good. Now, at this point, I want you to save this file. Give it a different name, but hang on to it because we're going to play with this some more next time we get together, Saturday. Okay? Hang on to this file. We need it like it is now, mapped. Because we're going to play some more with it. Now, we haven't finished our UV mapping process by any stretch of the imagination. We still have a bunch of work to do, but we're getting there. You will notice that different objects have different size squares. That's okay. But the squares on the same object all have the same size squares. That's important. Yes?
So I realized I have learned the difficulty of trying to make it perfect. Does it have to be perfectly like the same size or close? Perfect.
Make it as absolutely perfect as you can. Do your absolute best.
That's like depending on, especially on the cylinder, depending on where you move the face.
Mm-hmm.
Like what looks good up there in the corner might look really bad down here on the side.
The squares don't match up.
Yes. Well, you just got to, again, adjust the shells until you can get one square relatively near to each other, and then just try to get those two squares to have the same size squares. You know, will it match up everywhere? No, of course not. But if you can get one of them to line up, you know that the proportion is relatively correct.
We're only concerned with the proportions of the squares and how well they are aligned.
That's correct. We're going to talk more about the seams. We're going to talk more about alignment. We're going to talk more about those squares and why they're doing what we're doing. But at this point, I want to know that you can do this. This takes us a good way into the UV mapping process. We're nowhere near done. But this is important to get our feet wet right here and understand what we're doing and why. Does that make sense?
Yep.
Hell yeah?
Hell yeah.
Okay. So again, different objects have different size squares. That's fine. On the same object, the squares are all the same size. And what we're going to talk about when we get back together on Saturday is what the implications of that are. But to give you a hint, it has to do with resolution. You want all the sides of the object to have the same resolution. We're going to talk about pixels and resolution when we get together next time. Now, guess what your skill check is? UV map the jar. You remember building that thing? Your lecture 3 skill check, model the jar. Now you're going to break that bad boy out and UV map it. Right? Now, we're talking about the jar, right? What tool do you think you use? Cylindrical mapping tool for part of it, and planar for part of it. So things to think about. The outside of the bottom of the cylinder, that's going to be a planar. The inside of the bottom of the cylinder, also going to be a planar, because your jar has an inside and an outside circular shape. Also, your jar has an outside and an inside. You're going to have to cylindrical map both of those. Does that make sense? There are two cylinders, the inside and the outside. So when you're all done, you should be looking at 2 cylinder maps and 2 planar maps to put that thing back together.
What about this section of the jar that's like angled up?
That is still a cylindrical map.
So we're gonna have to go into the UV editor and grab the section where it's cylindrical, we're gonna have to shift it around so that the squares don't work.
Not necessarily. Yeah, try to map it. You will see. But this is what you'll be working on in lab, okay? So when you guys go to the lab, start working on this UV mapping, because your skill check for lecture 8 is UV map the jar so we understand how the squares part works.
Can we texture it as well?
I'd rather you didn't texture it yet, but we will talk about texturing and some cool stuff that we can do, and then feel free to do some texturing.
I would like to put in a Photoshop file and write David was here.
And that's how you would do that. Exactly. Does that make sense? We know what we're doing? What are we doing for our skill check for 8? UV map the jar. UV mapping, you will soon discover, is easier when you model well. Poorly modeled objects are harder to UV map. Poorly modeled objects are harder to generate textures for. So just be aware. There's a reason we teach you to model efficiently with beautiful edge flow. All of this stuff, mathematically sound geometry, yields easier stuff to work with. And I think the fact that we go into this UV mapping and texturing process, you start to realize why you model well, because it affects everybody. All right? So thank you very much, everybody. Get working on those UV mapping. If you have any questions, please ask the instructors in the lab to demonstrate for you, because for your week 4 assignment, you are going to be UV mapping objects that you built. And you better believe they're going to be harder than a cylinder and a cube. You got like hammers and stuff, so it's going to be more complicated, but it's the same 2 tools, same processes, same steps. It just takes a lot of tenacity between beginning and end. Yes? Week 3, you model a Lego person if you wish. Week 4, you can UV map your Lego person if you wish. Yep. So just be prepared. Week 4, lots of UV mapping. Week 3, more modeling. Way harder models. Start working on them now. Don't wait until you're getting close to the weekend. Start working on it now, because you're doing more complex models. They take way more time. So make sure you give yourself the time you need to be successful. Thank you, guys. I will see you digitally on Saturday. We will meet and we will talk more about UV mapping. Good job today, guys. I could tell you were focused. You were all in the zone. That's good.